So far we have seen classful addressing, right? And the problems with that classful addressing. That's why we are introducing now classless addressing. In classless addressing, we are going to have a prefix number n. What does it mean? I will tell you. So before that, first of all, we see where are we, going to get IP addresses. That is the question number one. Since IP addresses should be unique all over the world, that means so two devices which are connected to internet should not have generally, IP address same, right? So definitely forwarding will be difficult. That's just some simple common sense. Now that's why there should be authority. We have an authority for that. So that authority is going to provide us IP addresses. So I am talking about now 32-bit IP addresses. In IP version, there are two versions, IP version 4, IP version 6. In IP version 4, the IP address length is 32 bits. That means you can have 2 to the power of 32 patterns. Okay. So in this 2 to the power of 32 patterns, some group or some block of addresses now you are going to get. In classless addressing, there is no class system like, class A, class B, class C. There is no such distinction. Everything is same. Every pattern is same. Now, whenever you want some addresses, so from this available blocks, available addresses, some continuous addresses will be given to you. That's it. If you want 64 addresses, so you will be given some 64, I mean continuously, remember it. That is very important. Okay. So to give continuous addresses, okay, so for that what we are going to do is, why this continuous addressing I will tell you later, you will slowly understand it. So at this moment, remember, generally the addresses should be continuous. Now let's see one requirement. Example, let's say you need some 32 addresses, then you can ask authority. Generally you don't ask authority, so you ask internet service provider. That ISP person is going to get IP addresses from authority. That is the idea, that is a hierarchy. But at this moment, for simple discussion, we assume that, let's say we are a organization and we need some 32 addresses. Directly, let's say we ask authority. So authority is going to give 32 addresses continuously. For giving continuously, so what it will do is, they do like this. So they go to the place where there are continuously 32 addresses. For that, see, this is your 32 bits, right? 8 8 8 8. So the last octet, if you focus, let me extend it to bits. So bit 1, position 1, position 2, let's write 8 positions, 1 2 3 4 5 6 7 8. So your IANA, I mean that authority is going to give numbers such a way that this first 5 is going to be variable. Such a way it plans. That means out of the pool of addresses, it gives like this. Example, let's say there is a pattern called 129, so 192, anything. Okay, assume that randomly this is now available. 129 pattern, here 192 pattern in out of 8 bits, and something 224 pattern is available. And after that, let's say here, let's assume this is 101. Okay, this pattern is available up to this part. What is the meaning of 101? I am randomly selecting, don't worry. So this is 128, this is 64, this is 32, right? 128 plus 32, 160. So remember it. Now, if you ask 32 addresses, what that authority will do is, so they will give this way. First of all, they will try to vary these 5 bits, all zeros to all ones. How many ways they can vary? We know that 5 bits can be varied in 32 ways. So these 32 patterns are going to be your addresses. Try to understand now. So now if you want to know the IP addresses of each address or each pattern, we will see now. 129 dot 192 dot 224 dot. Now first bit, I am talking about first pattern, sorry. 128 plus 32, 160 plus entire thing is 0. The first address will be 160. Now next one, 129 dot 192 dot 224 dot. Next one, obviously this position will become 1, it will become 161, in that way continuously. The last address you are going to get is 129 dot 192 dot, this will not be changed, right? 224 will not be changed, but here it would become, see, all ones. Okay, remember it. Here the pattern is again, these 3 bits will not be changed, unnecessary, right? So 101. Now if I simplify 128 plus 32, 160 plus this extra 5 bits. What is the weightage of extra 5 bits? If you see, it would be 16, 8, 4, 2, 1. So it will be 31. 31 plus 160, 191. That means 160 to 191 will be provided. Sir, why this should be 101? It's up to you. So it might be like, see, 100. If it is 100, then what is going to happen is you are going to get 128 to, 1 followed by all zeros is 128 to all ones. Sorry, not all ones. It is 100 followed by that. These 3 bits will not be varied, but these remaining bits will be varied. It would become 1, sorry, 1, 2, 3, 4, 5. So it will be 128 plus 32. 31, it would be 159. So last one is 159. In that way, so we are going to get some block of addresses using classless addressing. So now what is the representation? How we represent? How we people understand that we have 129.192.224 of 128 to 129.192.224.159. How to write them? Do we any example you want to advertise them? Whenever you want to advertise them, we are going to do that. Are we going to do this one? I have IP addresses starting from 129 of dash to 128 to 129.159. How we express it? So the convenient way is like this. Take one of the IP address which is given for you, 129.192.224.128 slash. In CIDR, so we are going to have this important thing slash followed by this n. What is this n? I will tell you. How to fix this n is nothing but how many addresses you took? 32, right? So 32 is nothing but 2 to the power of 5. Agree? Yes. So this 5 to be subtracted from 32. 32 minus 5, 27. So here you should write slash 27. Sir, is there any easy way? You can easily understand like this. So this remaining part, other than I can say this is the part which is variable, right? So remaining thing is called prefix. Okay, prefix is not varying, right? How many bits are not going to vary? 8 plus 8, 16, 24 plus 25, 26, 27. This is going to be that number. Okay, now finally using this model we are going to represent our group of addresses. Okay, now we'll see one more time. This time, so we have another requirement. I want exactly 128 addresses. How I am going to ask that authority, we will see. Okay, we'll see one more example. Let's say we need 128 addresses. So this is the authority we are going to consult. Okay, so we are going to ask, my dear authority, please give us 128 addresses. So that authority is going to give us 128 addresses by this model. Since 128 is nothing but 2 to the power of 7, then 7 bits are enough to represent 128 addresses, correct? So that's why in the last octet the first bit can be anything. So the remaining 7 positions will be variable. 1, 2, 3, 4, 5, 6, 7. Now, so always your authority will try to give addresses starting with all zeros, okay, in that 7 positions up to all ones. Remember, that is very important. So these are all going to be your addresses if they are available. If they are not available, it will try somewhere else. Okay, so now finally all zeros, 7 bits to all ones, it is nothing but all possible patterns with these 7 bits. They are nothing but 2 to the power of 7, correct? So are you convinced with that? Now assume that, let's say this bit is 1. It can be anything. Assume that, let's say there is a block where this bit is 1, which is available with IA, your authority. Now here 128, 192 and something 64. In this, for this pattern, all these consecutive addresses are, let's say, available. Then you are going to get it. Okay. So somehow it gets it will give you, but how it will give, that's a separate story. It belongs to authority's idea. For us, finally, see, consecutive addresses are given, right? Now, so 128.192.64 dot, what is the first octet? What is the first address? Will be 128. This is going to be your first address. And if you want to know the last address, See 128.192.64. So this will be fixed. The first bit is fixed. Only these bits are going to be changed, and in the last pattern all bits will be ones, right? It would be 255. So I can say that from, forget about this entire thing, same, right? Only here you see 128 to 255, there will be 128 patterns, they will be given for you. We'll see one more example. Example, let's say you want 1024 addresses. How to handle it? So your authority is going to give you, 1024 addresses consecutively. For that, least significant bits are going to be varied. So 1024 is nothing but 2 to the power of 10, right? So out of 32, 8 plus 8 16 plus, you see, 8 24 plus 8 32, right? We want 10. Then the least significant bits, which are 10, here 2, correct, here 8, will be varied. Such a way your authority will plan. Okay. Assume that, let's say, there is a pattern called 128 here, 64 here, something here. Let me take blindly 10110, 1 2 here, 1 2 3 4 5, one more. Let's take 0. This pattern is available. Okay. So all these patterns are available. Then what are the IP addresses you are going to get? That's the question. Don't ask me, sir, why it is 128? Because your authority has availability at 128 pattern. So like phone numbers, and whenever you buy a car, otherwise vehicle, sometimes you consult your broker, otherwise authority, government, right? And you ask fancy number, correct? Otherwise sometimes you ask a pattern. If it is available, they will check the database and they will give. Similarly, so when you are asking 1024 addresses, they will somehow will go to the available blocks. They will maintain available blocks. They know that, let's say, somehow this 128 pattern is having, free. That means they are available. Simply they will get it. That's it. 128.64. Let's say. So what is the value of this part? We will see. What is the weightage here? 2 to the power of 7. Remember, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 square, 2 to the power of 1, 2 to the power of 0. Right? Now remember it. So what is the weightage of this value? 64 plus 16 plus 8. Right? 64, 70, 80, 88. So 88 plus something, right? Remember it. Now your first address is going to be 128.64. Okay. So 88 plus, remember one thing. In your first address, these two bits will be fixed, 0, 0. All these 8 bits are also going to be fixed to 0, 0, 0, 0, 0. That is a rule. Okay. 3 plus 8. Now what is the value here? 88 plus 0, 88 here. This octet will become 88 dot, what is this one? 0. This will be the first address. Second one, if you continue, so the last address will be 1 1 here, all ones, remember. Then only 1024 different addresses will be generated. It would become 128.64. Right? So what is the value if I write all ones here in this 10 bits? This is already 88 plus this one, weightage 2, 88, 90, 91, right? 91.255. So these are the addresses you are going to get, and especially these addresses are 1024. This is about classless addressing model. So we just started and we are going to learn so many things. One by one we'll learn. Now what we do is, whenever you have some 1024 addresses like this, how you are going to represent them? Simple. Take any of the address, not a problem. I will tell you how uniquely we can, how to uniquely represent it. Take any of the addresses. Okay. Why any of the addresses? I will tell you. Let's pick last address. You can advertise yourself, otherwise your numbers like this. My network is nothing but 128.64.91.255 slash, this is called CIDR notation. Write one address out of your 1024 followed by prefix. How to fix the prefix? Sir, what is prefix? First of all, try to understand what is host part. That means how many addresses you want? 1024. Then how many bits are required? 10 bits. So these 10 bits, especially from if you see from left, that means least significant bits, 10 least significant bits. Apart from that, how many bits are constant? This one, up to this point, all are constant. We did not vary them, right? So I can say that 8 plus 8, 16 plus here how many? 6, 22 bits. So otherwise 32 minus simply this 10. Okay. So 22 is going to be prefix and we are going to write 22 here. So this is called prefix notation 22. This is going to overall is called CADR notation. So this is very important. Without this, no one can understand how many addresses you are going to get. Understand? If I write here 22, whatever you got, then uniquely everyone can understand what is the pool. That means from where to where you are going to get the addresses from your authority. Okay. So we will see now reverse engineering. That means someone gives this advertisement. Otherwise, someone says that we have these addresses. Then how many addresses they have, what is the starting address, what is the last address, can we recognize? We will see. Okay. So far we have seen when we have a requirement how to get the addresses from the authority. Second thing, some network advertised that these are the IP addresses I have. Then how many they have and what is the starting address of that IP addresses and what is the last address of that IP addresses, we will see. Okay. Let us see with this one. So given CIDR notation, we will try to find out first question number 1. How many addresses this is going to represent? Second one, what is the starting address of that block? What is the last address of that block? Let's begin. So first one, how many addresses we are going to have? So it can be decided by this 27, which is nothing but prefix number. If prefix number is 27, first subtract from 32. 32 minus 27 is 5. Then 2 to the power of 5 is what? 32, correct? So 32 addresses we are going to have. Next, what is the starting address? If you want to know the starting address, so last 5 bits should be zeros. Remember, so for 32 bits, that means 32 addresses, 5 bits should be variable, right? So last 5 bits will be variable. Such a way only authority gives you. In the same way we can understand. So there is no other way of giving. Sir, what if authority changes, otherwise gives you variable part at most significant bits? That is not possible. It is a fixed rule that from least significant positions 5 bits, because you need 32, right? 5 bits will be varied and they will be definitely all zeros to all ones. No doubt on that. Okay. So that everyone can understand that. So this means there are 32 addresses and the starting addresses. Now what is the starting network? We'll see. What is the starting IP address? We'll see. Since this is not changed, right? 167 as it is, 199 is as it is pattern, 170 pattern is as it is. Now we will see this last positions we have to observe 1, 2, 3, 4, 5, 6, 7, 8. Sir, what is this 82? Already I told you. This is one of the IP address which belongs to your 32 addresses. That's it. So 82 is definitely one of the address. Let's write 82 first. So 82 if I write, it will be, we know like 64 plus dash is 82, 64 plus 18, 72 plus remaining 10, 8 plus 2, right? I am writing 82 as sum of two powers. First of all, let me write it. We know that when you have 8 positions, you are going to have weightages like this: 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So 64, that means 2 power 6 weightage 1. So here 64 plus 16 here, right? 80. 64, 70, 80, 88, 82. 16, 2 to the power of 4. Okay, you write 1 here. 8, 2 cube. 2, 2 to the power of 1. Here you write 1. So all others are zeros. Then it will be 82. Okay. Now we know that in our IP addresses, starting address is nothing but such a way that last 5 positions are zeros. Let's make all zeros. 1, 2, 3, 4, 5. So it will represent the first IP address in this network. 0, 1, 0. All zeros. The meaning of that is definitely, if I convert it into decimal, it would be 64, right? So finally, the first IP address is 167.199.170. In this one, 64. If you want to know the last address, so definitely write all ones. this host part. Now I can say these 5 bits are host part, right, all ones. Then you get a pattern which is nothing but 64 plus this all 31, right? 64 plus 31, 95. So we are going to get here 167.199.170.95. Okay, so in that way, given CIDR notation, we can find out how many addresses we got and what is the starting address, what is the ending address of IP addresses. Okay, we will see one more example. Example, let's say you have 162.128.64. Something 80 slash something 21. What does it mean? We will see. Question number 1. Only 3 points you should know. One is, if you have these many IP addresses, then how many we are going to get? Second one, what is the starting address, what is the ending address? Okay, so for that, first of all, we go to prefix 21. So remove from 32 minus 21, it would be 11. That means, so 2 to the power of 11 are going to be total addresses you are going to get. I can say that the formula for getting total number of addresses is 2 to the power of 32 minus, so this 21 is nothing but prefix number, right? Prefix number, which is nothing but here, this one, n. Okay, so 2 power 11 is nothing but 2048. So we are going to get 2048 addresses. Second point, what is the starting address, what is the ending address? If you want to know the starting address, first of all we write, pattern 8. I'm interested in last 11 bits, right? 8, 16, so 24 and 32. So this 8 and this 3. Okay, so let's divide this as 5 and this entire thing is host part, I can say, correct? So now let's write what is 162, because we are not going to disturb 162, keep it as it is. So we are not going to disturb 128, keep as it is. Now we are going to disturb this part, right? So first write 64 here clearly. How to write 64? 64 is nothing but 2 power 6, correct? If you see the weightages, it would be 0, 1, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, right? So this is 64 dot 80. How to write 80? 64 plus 16, correct? Simply 0, 1, right? 0, 1, 0, 0, 0, 0. If you have doubt, you can check. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 16. 2 power 5, 2 power 6, 64 here, 16, right? You know the binary weightages. So 80. Now starting address, if you want to know, then the first 11 bits should be zeros. Simply go to first 11 bits. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this part don't disturb as it is. 0, 1, 0, 0, 0, right? So this is going to be the first address. So if I write it, it would be 162.128 dot. So here. So this is as usual, right? Same thing we got 64 dot. This is definitely 0. This is the first address. The last address will be 162.128 dot. So all ones here 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. It would be like this. This will be definitely 255, last component. The middle second component is 64 plus this last 3, 7. 64 plus 7, 81. So we are going to get the last address 162.128.81.255. Here first address 162.128.64.0. In that way, given CIDR notation, you can understand how many addresses we have, what is start and what is end. Okay, we will learn more details about this addressing and all. Let's begin with one more example. Let's say 167.199.170.82 slash 23. Okay, in this one, here I would like to tell you two important patterns. Okay, before that, first of all, how many patterns we have? So 32 is nothing but total number of bits, minus 23 if I do, you get host part. Host part is 9 bits, network part 23, I can say, correct? So this 9 bits are going to give you 512 continuous addresses, and what are they? We will see first. That addresses are 167. Let me write a binary pattern here. How to write 167 in binary, you know, right? So remember it, 167 can be written like, so 128 plus 32, 160 plus 7, 4, 2, 1. So these positions in the weightage should be 1, right? So further it would be 1. First bit is 128, yes, it is on. Second bit 64, off. Third bit 32, on. Fourth bit 8, off. Next bit is 4, on. Next on, next on. That's why it is 7. See, 7 plus 32 plus 128. In that way, we are going to write for everything. 199 can be written as 128, right? 64, 192 and 7, 4 to 1. So, it would be 1, 1, 0 and 0. Then 1, I can say 128, 64, 32, 16, 18, 8, 4 to 1, triple 1. Next, dot 170. 170 can be written as 128, 32, 160, 160 plus 10. 10 is nothing but 8, comma 2, right? It means 1, then 0, then 1, then 0, then again 1, right? 8 means. So 64 is absent, 16 is absent, 8 is present, then 4 is absent again, right? Then 2 is present. This is 10, 10, 10, 10, followed by 82. 82 is nothing but 64 plus 18. 18 is nothing but 16 plus 2. So we write like this: 0, 1, and then 0, 1. After that 0, 0, 1, 0, right? So finally we got IP address in binary pattern. Now what I want to tell you is, what is the starting address? If you want to know in this network, definitely the 9 bit should be identified first of all, correct? So 23 means what? 32 minus 23 is nothing but going to be 9. 9 represents total number of host bits. 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 9. So these 9 bits are going to be host part, remember it. So if I make all of them to zeros, then you are going to get the first address. First of all, let's try to find out the first address. It would be 167.199.170 dot. Here it is, this part you see. This is 82, correct? Sorry, not 82. This is 170. It is done. This part, if 0, correct? So this is the starting address. Similarly, what is the last address? 167.199, same dot this part. In that we are going to have, how to get last address? All 9 bits should be ones, that's it. Okay, so you are going to get 255 here. This part we have to see. This was 170, now you added one more, right? 171. So what I want to tell you is, this is the first address, this is the last address in the contiguous sequence. Now here one interesting thing I would like to tell you, these two patterns are not going to be used for your devices. Generally, why we require IP addresses? We want to use them for our devices to connect to the internet, right? So you are going to form now a network with 512 devices at most. So assume that, let's say this is a logical idea about your network with 512. But generally you can't have 512. The reason, two patterns out of 512 should have different purpose. So this is for especially to identify network. So this is not a, I can say, IP address of a device. It is from now onwards, you remember, an IP address of network. Okay. So this is network address. This is going to be broadcast address. Example, in your network, if you want to have a broadcast, for that this address will be used. Okay, whenever a packet comes from with this address, so then that will be represented as a broadcasting, and automatically that packet has supposed to be broadcasted over all the devices of your network. Remember, all the devices of only your network. Okay, that's why, remember it. Every network will have, that's why, a pattern which is for broadcasting, one pattern for network itself to represent. Remember. Now I'm going to introduce you a concept called mask. So this mask is useful for some of the interesting operations. Okay, so for your computer, generally bitwise operations are easy to do, right? So that's why your computer, otherwise in software we are going to use this mask. Generally in implementations, to extract some of the IDs and all, we use mask. First of all, try to understand what this mask is going to do, okay, so that you can understand where we use it. Let's learn first what is mask. Okay, mask is simply a binary pattern with 32 bits where the host part is zeros. That means how many bits are there in host part in your network? 9, right? The first 9 bits from right to left. Otherwise I can say least significant bits. The least significant 9 bits will be 1, 2, 3, 4, 5, 6, 7, 8 and 1. 9 will be zeros. All will be ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, followed by 1, 2, 3, 4, 5, 6, 7, 8, dot this one, not 8, 7, followed by this 0 will come, right? Now see, these 9 are zeros and remaining are ones. This is called mask for this network. What is the advantage of this mask? You see, example, let's say you have a mask, okay, then try to do bitwise AND between your one of the IP address in your network with this mask. What happens, we'll see. Automatically 1.1 1, right? 0 and 1 is 0, 1 and 1 1. So if this is 1, you are going to get 1. If this is 0, you are going to get 0. That means you are going to get your pattern back. That means I can say you are going to get 167 here and automatically 170 here, sorry, 199 here, and you are going to get here, see, 10 10 10 10. This part you see, this is last bit is 0, we know that, right? So 0.0 0, you are going to get same, but this remaining part automatically you are going to get back because you have all ones here. That means again that 170 will be coming back, dot. So we know the remaining story, whatever may be the pattern here. So your this will be a representation of one of your IP address. Dot 0 will give 0, right? 0.000. What I want to say is, because of that 9 zeros, then that 9 bits are going to be in your IP address will be zeros that represent starting address. That's it. What I want to say is, if you do AND of mask and any IP address in your network, always you are going to get this same. Okay, that is nothing but, remember, your network address. From now onwards, your computer can find out, otherwise any router can find out the network address of any network by simply ANDing one of the IP address where that one of the IP address where which belongs to that network, so called network we are talking about, and that AND with mask. That's it. So remember it, that is important. Second thing, so using OR operator also we are going to have some important result. Let's take bitwise negation of mask. So what is this bitwise negation of mask here? Simple. Ones will become zeros, zeros will become ones. Let me negate the mask. 0 0, that means 8 zeros dot 8 zeros dot 8 zeros, right? Not 8 zeros. 7 ones followed by 0 will be 7 zeros followed by 1. Okay, dot. All these zeros will become, let me add one more 0. All zeros will become 1. This is negation of mask. Once you have negation of mask, what I am going to do is, I am going to do OR with your IP address. Okay, one of the IP address it can be. Let's take this IP address and do OR. What happens, we'll see. Surprisingly, if you do OR 1 0 1, you get 1 back. 0 0 0, OR operator this time. So if you have 1, you are going to get it back, and if your bit is 0, then 0 plus 0 0, correct? 1 plus 0 1. That means if you do OR operation, then you are going to get this network part back, right? 10 10 111. Remember, in your network part we have all zeros. When you OR them, you get network part back, 167 dot. Here this 199, which is your network part, will be back. But here this 170 is not your network part, right? Only some part is network part. 7 bits are network part, right? They will come back. That means, what is, if that 7 bits comes back, what happens, we'll see. 10 10 101. These 7 bits will come back, but the last bit we don't know, right? 0 and this one. Here we have 1. 0 plus 1 1. right? You got extra, remember it. Next, since all these bits in the host part are ones, 1 or anything is 1. So what I want to say is definitely these 9 bits are going to be ones, remember. So what you get is 167.199 dot. This is nothing but, if I simplify, you get 171. 170 plus 1, and this entire thing is 255. So that is nothing but broadcast address. So finally, broadcast address generation and generation of network address are quite easy, right? So that is why this mask is very important for us. Just remember it. Using mask now, you realize that we can easily create network address and we can easily create broadcast address. Remember it. Okay.